Hello guys, so let's discuss today's POTD, that is 474 ones and zeros. So it is marked as medium. You are given an array of binary strings strs and two integers m and n. Return the size of the largest subset of strings such that there are at most m zeros and n ones in the subset. A set X is a subset of a set Y if all elements of X are also elements of Y. So what you have to return? You have to return the subset, longest subset of this array, such that the total number of ones and zeros are equal to m and n. Means the total number of zeros in that subset should be m, and the total number of ones should be less than or equal to this n. So you have to return the longest subset. So let's see the first example test case. You are given a string strs, the string vector, and m and n. So the first as given in the explanation, the optimal way to choose the elements are 1 0 0 0 0 1, this one and this one. Let's count the total number of zeros in this subset. The 1 here, 3 3 plus 1 4 and 5. So we can take this subset, and the n should be less than equal to 3, that is 1 2 and 3. So we can take this subset, and the length of this subset is 4. That is our answer. Similarly, the second example test case is just like that, and the constraint are the string length is 600, and the array length is 600, and the string length will be maximum 100, and the string will only consist the 0 and 1s. So the first approach as a beginner, what we can think that this might be a greedy question, means the greedy solution should exist. So the first thing that came in mind is the greedy solution. So what greedy solution can we implement? That is, we can take the smallest string, means the smallest we can take this string in the lengthwise, whose length is smallest, we will take it first. But this will fail in many test cases. Let's assume like here it is this greedy solution will work. Why? Because we will take this one, this 0, that is and then we will take this, and then we will take this, so it will work here, but it will fail in many test cases. For example, let's assume the vector is 0 0 0 0 1. Let's like the 0 1 1 1 1 and 1 0 1 and 1 1 0. And suppose the m number of zeros you can take is 1 2, yeah, 2 zeros you can take, and the n you can take is let's say here also 0 0 1 and 0 1 1 1. Yeah, so m you can take 1 2 3, m you can take 3, and means the 0 you can maximum take 3, and n you can take 6. So according to the greedy solution, I'm making this test case just now, so it might work or not in this greedy solution. So let's see. So first I will take 0, that is, now I can take 2 more zeros. So the second smallest length is this, so this will be our answer. Now I can take 6 ones, but I cannot take this, I cannot take this, because this consists 0 and I can't take 0 because I have taken all 3 zeros here, and I cannot take this and I cannot take this one also. But if but the answer of this will be 0 1 1 1 0 0 1 0 0 1, and length is 2. I can take 3 na. I cannot take this one, I can take this one. 0 1 1 1, and I can also take this one. The answer will be 3, but through our greedy solution we were getting that 2. We were getting this. The greedy solution will give us this, but our optimal answer is 3. So the greedy will fail here. Now this means we have to check all the possibilities. Means we can take this, or we can take this and this also, we can skip this one. So now we have reached in this position that we have to take all possibilities, we have to consider all possibilities. So now for considering all possibilities, we can take help of recursion. So what I have done in recursion, what we will do is we will take this, or we can skip this. So now we can consider this problem as a 0 1 knapsack. So the recursive solution for this problem will be the 0 1 just like that, the 0 1 knapsack, but the recursion will fail. So we have to memorize our solution. So now it's a DP solution, means now we have to write a DP solution for this. So let's move to the coding part. So I have created a DP vector, 3D DP vector. The first I wrote this recursive solution for this. So let's remove this for now. I wrote this recursive solution. So I am passing 0 strings this vector and m and n, and I'm starting the count of 0 and 0, means the total count that I have to that I am allowed to make. So the count of 0, this is the total count of 0, this is the total count of 1. So in my recursive function, I am this is my base condition. If my I is equal to v dot size, means the length of the vector, then I am returning 0. Otherwise I am taking or not taking, and I am also counting this current the count of zeros in the current string and the count of ones in the current string. So I'm iterating in the current string, means like I'm iterating in this string here and counting the current 0 and current 1. If my total count and current count is less than m, and the total count of 1 and current count of this 1 is less than n, then I can take this string in my answer. So I'm taking this and moving to I plus 1. And also I am adding this current count of 0 and 1 in my total count. And not take condition is simple. I am just moving the I to I plus 1. So this is the recursive solution, and now I have to memorize it. So for my memorization, we have 3 variables that are changing, that is 1, a count of 0, and count of 1. And that is I, count of 0, and count of 1. So the index and count of zeros and ones are changing. So we will take the 3D DP here. So I have made this 3D DP, and I'm passing this in my recursive function, and I'm checking if my this DP contains is not containing -1 for the current state, then I'm returning this the answer. Otherwise I'm storing my answer in the DP vector. So this is the memorization solution for this. And The time complexity for this will be O of this O of n cross m and the maximum length of this string, and the space complexity will also be O of n cross m cross the string of this vector, this given vector. So the time and space complexity will be this, and we can also optimize this a little bit. What we can do is we can count this, we can make a new vector in which we will store the count of zeros and ones of the current string. Like I can make a new vector in which will consist my this string plus count of consist this string and count of zeros and count of ones. Means what I can do, what I'm saying is I can make a vector like this which will contain my string, count of 0, count of 1, this I can make, and I can pass this vector here, so that I will not have to calculate this count of 0 and count of 1 every time, and I can get rid from this loop, and this loop that I'm using here to count zeros and ones for the current string. So this is we can optimize it. So this is the solution for this problem. I hope everyone will get it. It's not that hard question, it's easy to medium question. Yeah, so this is the solution for this. Thank you.